Today we'll learn about wave scattering by simulation of waves when it encounters different objects of different sizes. This simulation is done in a software called MEEP, which is a simulation software used to simulate time-domain electromagnetic waves in 1D, 2D, 3D or cylindrical coordinates. It uses a technique called finite difference time domain to model the field patterns, which are nothing but a solution of Maxwell equations for finite time domain. So scattering occurs when size of obstacle is larger than the wavelength. The particle-particle collisions between molecules, atoms and electrons and other particles cause it. The angle through sunlight scatters varies inversely with wavelength, resulting in phenomena like blue sky and the red color of the sun when sunrise and sunset, which is caused due to scattering of light from dust particles in the atmosphere, and the white color of clouds is caused due to scattering of light from water molecules. The MEEP code is given below. The lattice size is 20 by 20 and the size of the object is 8 times the size of the wavelength, which is 1. The perfectly matched layer is made 1 unit thick around the lattice and the resolution is set as 10. So here we can see the wave does not travel behind the object and a clear interference pattern is formed between the source and the obstacle. Now we'll talk about diffraction, which occurs when size of the obstacle is comparable with wavelength. It is like bending of light around obstacles or passing of a light from a small slit. In the MEEP code, we have given the size of the obstacle is 0.8 times the size of the wave, which is 1, and the lattice size is 20 by 20. A perfectly matched layer of thickness 1 is put around the object and the resolution is set as 10. Here we can clearly see, although the object does not block out the wave completely, a part of it is still behind the object, thus giving the illusion that the wave is bent around the object. Now here we can see if the size of the obstacle is very small compared to the wavelength, it appears to have a very small effect on the wave and the wave remains unchanged. In the MEEP code for simulation of this obstacle, we have used the size of the obstacle as 0.2 times the wavelength size and the lattice size is 20 by 20, the perfectly matched layer thickness is 1 and the resolution is set as 10. That's all for this video. Thanks for watching.